Hi class, as we prepare to start our new unit on organic chemistry, we're going to take a look back to see how all of the material we've learned this year is going to connect to this new and exciting unit. Organic chemistry is its own field of chemistry, and in organic chemistry, all of the compounds will contain both carbon and hydrogen. In organic chemistry, all of the compounds derive from living things. Organic compounds include petroleum, which makes gasoline, coal, wood, plants, and animals. After all, petroleum and coal are fossil fuels. They are produced from fossilized animals. In the next 3 lessons, we are going to review the characteristics of ionic and covalent bonds, why bonds form, and how to determine the gram formula mass and empirical mass of compounds. So in this video, we will describe why bonds form. A bond is a force of attraction between 2 atoms. A bond is a force of attraction between a positive nucleus and negative valence electrons. Recall that valence electrons are the only part of the atom that actually participates in bonding. In a bond, it is always true that the more electronegative element will pull the electrons towards its nucleus, while the less electronegative element will release its valence electron. So in a bond between sodium and chlorine, the more electronegative chlorine pulls on sodium's valence electron. Bonding always occurs so that elements can obtain a full, stable, noble gas valence electron shell. Notice that a sodium atom typically has 1 valence electron, and a fluorine atom typically has 7. As sodium releases its valence electron and donates it to fluorine, both of the electron configurations change to 2,8, the same as the noble gas neon. Atoms bond because when they bond, they have less potential energy. The excess potential energy will be released after a bond is formed. Here you can see when you combine sodium with chlorine in a chemical reaction, a lot of heat and light is given off as the compound sodium chloride is formed. Now, in the reverse situation, if you'd like to break a bond, you're going to have to add energy. Breaking bonds increases the number of positions the particles will have, so energy must be added in order to increase the potential energy. If you'd like to break these bonds between the hydrogen and the oxygen, you're going to have to add energy. So by now, you should be able to describe, in terms of electron configuration, why bonds form.